Hello, in this video, we are going to discuss product power law and fractional index. The first one we are going to work on is having a shape of this kind, a to the power of m, n. Now look at the model to the law. Now we have a to be the base, as we've discussed in our previous videos. This is the last laws I'm going to discuss under indices. We've discussed the first law, which is the product law, and also the second one, the quotient law. We've discussed the zero index. We also discussed the negative index. And then the last one is going to be this product power law and the fractional index. If you've missed those videos, I'm going to drop the link to those videos in the description of this particular video. So please follow the trend. Now we have the base and these are the powers. In some cases, or let's finish up with this. What is the model to this? By the time we have this parenthesis, it details or entails that this m, which are the powers, are going to multiply themselves. How do I going to achieve that? So we have a to the power of m times n will give us mn. So that is just it. That's the model. That's how it is. For example, if I have 2 to the power of 3 all squared. So how am I going to approach this problem like this? It's simple. You could be able to say 2 to the power of 3 times 2 to the power of 3. That is to say, this duplicating itself 2 times. You simply can do this and then finally say, because the bases are the same, you could just take the common basis and add the power 3 plus 3, and this would be 2 to the power of 6. And what is 2 to the power of 6? That should be 64. Alright? So notice the process we go through in order for us to achieve this. But with this rule, we could just go one line, then we have the answer. How do we achieve that? 2 to the power of 3 times or multiplied by another power, which is 2. It's simple. You could just easily say from this format or this model, 3 times 2, that will give us 6. And 2 to the power of 6 is 64. You still get the same answer instead of saving you the stress of going through this process. So that's all about this law. Very simple. All right, let's see the last one, which is fractional index or fractional indices. I've already told you that indices is a plural form of index. Index, exponent, power, they are singular form of these indices, and they are talking about something that operates at the top. So in fractional index, the model to this law is this. If I have a problem as this, m divided by n, you can see that m over n is operating as a power, and this is the shape of a fraction. Fraction is when the shape of the form of a fraction is when a numerator divides a denominator, and fraction is just part of a whole number or part of a set of number. That is what fraction basically is all about, right? So we having this. What is the implication of this denominator? We are concerned about the denominator in this case, which is this n, and this will apparently change the n here will change to become the nth root of a all to the power of m. That's what it is. How did this suddenly change to the nth root? Okay, let's look at it here. If I have a to the power of 1 over n, we've already agreed in one of the videos I've done, all right, about change of subject formula. We say that when we have things like this or something of this sort, 1 over as a power can easily change to the nth root of that number. So what if we have a to the power of 1 over 2? This can easily change to the square because it is, we are concerned about the denominator. You change to the square root of this a. What if I have a to the power of 1 over 3? It will change because it is 3. It will change to the cube root. You know, of course, square root, we don't like writing 2 here. But by default, this is how we write square root. So this will change to become this. So similarly, when we have n, it changes to the nth root. If I have a to the power of 1 over m, it can change to the nth root of this a. I hope that makes sense to you. So this is how this n changes to this one, the nth root of this a to the power of m. So if I have 2 here, here becomes square. If I have 5 here, here becomes to the power of 5. If I have 7 here, here becomes 7, as the case may be. I hope that makes sense to you. All right, so this is the idea. So what if we represent it in terms of numbers? Say we have an expression like this: 8 to the power of 2 over 3. So how can we work on this expression? It's simple. Because we are having 3 at the denominator, just change it to become the cube root. Remember, if it were to be 2, it will change to the square root. If it were to be 5, it will change to the fifth root of this 8, all to the power of 2. So, without calculator, how can you be able to check what the cube root of 8 is? It's simple. Cube root means 3 consecutive numbers that looks alike that can multiply themselves to produce 8. So I can think of 2 to be that number. 2 multiplied by 2 is 4, by another 2, that's 8. So I could just pick that number, one of those 3 numbers, which is 2. Raise to the power of this 2, and the result will give us 4. Alright? So that's how simple this law could be. Maybe if you want extra problem, so I will end this video with just one question, and that would be, let's say 27 to the power of, what can we use here? Let's say 4 divided by 3. Now, because we are having the base here to be 3, we have done something like this before. Let's change, or let's work on this. You have to change it to be the cube root of 27, all to the power of 4. So at that point, what is the cube root of 27? Think of 3 numbers that can multiply itself to give you 27. And that will be 3, because 3 multiplied by 3 is 9, multiplied by 3, that's 27. So you just pick one of these number, one of those numbers, just pick one of it, which is 3 to the power of 4. And what is 3 to the power of 4? It's simple, that is 81. How? 3 times 3 times 3 times 3. That is the meaning of 3 to the power of 4. Here is 9, here is 9. 9 times 9 is 81. So you can see how simple these laws could be. So if you enjoyed this video, and if this video makes sense to you, just subscribe to my channel, like the video. Peace.